As we already know what is loss function, we are checking what is the difference between the predicted output and the original output. If the loss function value is low, it means the predicted output and the original output are almost equal. If the loss function value is high, then the predicted output is far away from the original output. So we want to find this loss function for all training samples. So I am using sigma I is equal to 1 to m, means for m training samples. Now after finding the loss function for m training samples, we want to average the all training samples loss functions value. So this average is called as cost function. Because the loss function is depending on only parameters w1 and w2 and b, the cost function also depending on only parameters w1 and w2 and b. When I am differentiating this cost function with respect to w1, we are using the partial differentiation because this is depending on w1 and w2 and b. I want to make w2 and b as constant. I want to differentiate only with respect to w1. So I am taking dou by dou w1. So when I am differentiating with respect to w1, the individual loss functions all are differentiated with respect to w1. Now we are discussing how to write the code for this. Initially the cost function value is 0. Initially we are taking dw1 equal to 0. What is this dw1 in reality? The change in the cost function with respect to dou w1. So if I express this, you already, I think we discussed already about this. We can express this dou j by dou w1 as this is dou j by dou a, and we can express this as dou a by dou z, and this dou z by dou w1. This is how we calculated the value of dou j by dou a into dou a by dou z. We have calculated that value as a minus y. So we are calling this as dz. So whenever we are calculating the dw1, it is the product of a minus y into x1. So a minus y, we are taking it as a dz. So you can remember, if you remember that equation, the programming will be easy to you. Now we are taking the for loop for all training samples. We want to calculate this. So I am taking for I is equal to 1 to m. Okay, individually, if you take first z is equal to omega transpose x plus b. So omega 1 x1 plus omega 2 x2 plus b. And we are calculating the a is equal to sigma of z 1 by 1 plus e to the power minus z. And next we are updating the cost function j is equal to the value minus y log a plus 1 minus y log 1 minus a. Now we are calculating a minus y. We are multiplying this a minus y with the x1. When we multiplied the a minus y with the x1, we have calculated the differentiation of the cost function with respect to w1. When we multiplied this a minus y with the x2, we have calculated the differentiation of the loss function with respect to w2. And when we considered this a minus y, then we have calculated the differentiation of the loss function with respect to b. After calculating the cost function changes with respect to w1, with respect to w2, and with respect to b. Now we want to calculate the average value of the cost function. This, what is the average value of the cost function for each and every training sample? So that is j is equal to j by m. And we want to calculate the differentiation of the cost function for all training samples. So we are writing a compound assignment we are using a compound assignment operator, and we are writing dw1 is equal to dw1 by m. So we are doing the average. And finally dw, because we are using here also compound assignment operator, we are accumulating for all training samples, we are taking what is the differentiation for the first training samples, and we are adding to that to second training samples, and we are adding that to third training samples, and finally we are performing the average on DW1 and DW2 and DB. Now already we know in the gradient descent step we will update this DW1. What is this DW1? This is the differentiation of the cost function with respect to W1 for all training samples. Remember, for all training samples we are updating, and we are differentiating the cost function with respect to W2 for all training samples. The differentiation of the B with the differentiation of the cost function with respect to B for all training samples we are taking. So if we take this DW1 and DW2 and DB, this is only one step, but we want to repeat this loop. How many times we want to repeat this loop? Until we find the minimum value, until we find the W1 is equal to W1, means this differentiation is becoming 0 until that. So until we find the minimum value of the cost function, the loop will be iterated, and finally we get the W1 and W2 and B values, and if we substitute these W1 and W2 and B values, we can get the exact function which can predict the output. But remember, here we are taking one for loop for I is equal to 1 to m, because we want to calculate the cost function for m training samples. We want to calculate the differentiation of the cost function with respect to W1 for m training samples, and the differentiation of the cost function with respect to W2 again for m training samples, and the differentiation of cost function with respect to B for m training samples. We are using a for loop here. Because we have only two parameters, it is okay. But in reality, we may have 1,000 or 10,000 or 1 lakh features. So when we have more number of features, when we have taken more number of features, at that time we cannot write DW1, DW2, DW 10,000, DW 1 lakh. Again, we have to use the another loop here, a loop within another loop. So there comes the nested loop concept. Because n is equal to 2, we are not considering a loop here. But if the features are incrementing, if the parameters are incrementing, then we have to consider the another loop here. It is making us to our program very complicated. It is appearing like it is a lengthy program. Is it possible to reduce the code of this program? Yes, it is absolutely possible, because the deep learning is dealing with the data, with the huge amount of the data. If we go on using these for loops, then the system time, the time that is taken by the system will be more. So this can be reduced. We can replace the for loops entirely by using simple 1-2 commands. That can be possible with the vectorization. We will discuss about vectorization.